Now, you're going to be told to find the roots of a quadratic equation, or you're going to be told to solve a quadratic equation. And how do you do these two things? How do you find the roots of an equation, or how do you solve an equation? And see, first of all, let's look at this roots idea over here. Let's look at this for a second. So we know what roots are, and we know roots are basically the roots of a quadratic equation are basically the points or the places where the quadratic equation cuts the x-axis, or touches the x-axis, or intercepts the x-axis. So we know that each quadratic equation has its specific smiley face or sad face, and based on those smiley faces or sad faces, we can sort of draw a graph and see if our smiley faces cuts the x-axis, and then we can sort of see that, okay, this point right here would be our first root, that point right there would be our second root. Check the values, let's say this is 2, that is 3, and then say that, okay, we got two roots, which is x is equal to 3, and x is equal to 2, and x is equal to 3. Sometimes we may even have quadratic equations that look like this. And in this case, we know we're going to have no roots because clearly the curve or the smiley face or the quadratic equation does not touch the x-axis at any point. Sometimes we may have situations like this, and so we may know that, okay, now our quadratic equation or our smiley face touches the x-intercept or the x-axis at one particular point, and let's say this point right here is 1, so we can just say that x is equal to 1. Now that's one way of finding roots, and that's by just looking at the graph, looking at the smiley face or the sad face, and then just seeing, visualizing, and seeing where it touches the x-axis, and just going up and picking that point, saying that, okay, this is your point, and this is your root. Now the problem is you can't always see, so you can't always see. Because every time they're going to ask you to find roots, you can't always draw a grid with axes and then label the markings and then, you know, check out your y and x values and then draw a smiley face or a sad face. If you do that for every question, that's going to take a long, long time. So you can't always do that. You can't always see the quadratic equation. You can't always have a graph. Instead, you want to just have your quadratic equation, and just by looking at that quadratic equation, you want to be able to tell where the roots are. You want a method that allows you to just look at the quadratic equation and then allow you to find the roots by just, you know, using that quadratic equation, not using any graph or looking at the graph or looking at the smiley face or anything like that. And you can actually do that. And that basically takes on the simple idea that these roots are basically places where your smiley face or your sad face cuts the x-axis. And so if you realize you have this x-axis over here, right, the x-axis, and this is your y-axis. And so ask yourself this: at the x-axis, what is the y value? So at the x-axis, what is the y value? And let's say if this is this is the origin, this is going to be 0, and then this is going to be 1, 2, 3, this is going to be -1, -2, -3. And we know that at the x-axis, or at the x-intercept, the value of y is always equal to 0. So the y is always going to be equal to 0 at the x-axis. And this information, we can actually use this information and put it into our quadratic equation. And how do we do that, you may ask? Well, so let's say I have a quadratic equation that looks something like this. So we have x squared minus 6x plus 8. And I've been told that I need to find the roots of this quadratic equation. And what I'm going to do is I know that without seeing the graph, without doing anything, I know that I can find the roots of this quadratic equation. And the only thing I have to do is I have to say, okay, well, I can put this thing equal to y, just like I do when I'm making my graphs. I put my quadratic expression equal to y, but I'm not actually going to make a graph. I know that if y is equal to 0, that's where my roots are. That's where my roots are lying. That's where my roots are present. So all I need to do is I need to put this y value equal to 0, and I'm going to be left with x squared minus 6x plus 8. Or I can flip this around and write it like this. Okay, and all I've done is I've basically said that my y value is equal to 0. My roots are lying at that value. My roots are positioned at that point where the y value is equal to 0. And what is that point where y value is equal to 0? It's basically the x-axis. Okay, so I've basically created this thing, and this thing is so important because this equation right here is how you find your roots, or how you solve your equation. Solving your equation, basically, in other words, means go ahead and find the roots. So whenever you are trying to find the roots of your equation, you're trying to solve your equation, do this thing right over here. This is so important. I cannot stress how important this is. If you have anything other than 0 over here, then you won't be able to find the roots, right? Because the roots are at the x-axis, and we know that at the x-axis the y value has to be equal to 0. So you need to get your equation into this form, equals to 0. You need to get it into this form before you can go ahead and find the roots, or before you can solve your equation. This is the first step that you need to do. Now, once you've done that, all you need to do is you can either go ahead and convert this equation into its factorized form or in its root form. So you can either take it into its factorized form, or you can convert it into its completed square form. Right? Those were the two forms we learned about: completed square form. And the thing is that you cannot find roots. The first thing was put in your equation equal to 0. The second thing is you cannot find your roots in the standard form, or you cannot solve the equation in the standard form. You can only solve it, or you can only find the roots if you have, one, the factorized form, or you have the completed square form. Now, if this equation right over here was already in its completed square form, that would have been perfect for us. Or if it would have been in its factorized form, that would have been perfect for us. But since it's not in that form, we actually have to convert it into one of these two forms. And that's the only way we can find our roots. So what I'm going to do is I'm just going to factorize my equation. You can go ahead and do the opposite step and see if you get the same answer or not. But remember, whenever you're trying to find roots, you have to convert your equation into either the factorized form or the completed square form. So I'm just going to factorize my equation, and it's basically, I have my x squared minus 6x plus 8 equals to 0. So I know that this x has a coefficient of 1, and this is a plus 8, so 1 multiplied by plus 8 is equal to 8. Now I just need to find two numbers that multiply to 8 and they add up to -6 because that -6 is my b value or the middle value. So I'm doing middle term break. And that's basically going to be -2 and -4. You multiply them, you get +8. You add them, you get -6. So this is going to be -2x, -4x, +8 is equal to 0. And then I can take out my commons. So this is just going to be x minus 2. And so this is going to be x minus 4 and x minus 2 is equal to 0. I hope I didn't do anything wrong over here. Let me just take a quick recheck. So that's x minus 2. And okay, I don't think I did anything wrong over there. Right, now what do I need to do? Now I'm in this final step. Now for a second, let's say this thing right over here is your A, and let's say this thing right over here is your B. And they're equal to 0. So imagine this, if you have two things that are multiplying to each other, A and B, and they give you an answer of 0. Now you don't know what the value of A is, you don't know what the value of B is either. But here's the catch. Now if two things are multiplying and you don't know what those things are, but you know that their answer is going to be equal to 0, then there's two possible cases in which that can happen. For the first possible situation is that A is equal to 0. Now I don't know this, right? I'm just assuming this. So if A is 0, then obviously you can, when it's going to be multiplied with B, it's obviously going to be 0, and so it's going to be equal to 0 on both sides. Or the other possibility that can exist is that B is equal to 0. B is equal to 0. And if B is equal to 0, then I can just have A is equal, then A is going to multiply with B, and B is obviously 0. So this is B, B is obviously 0, and so your answer is going to be 0 equals to 0, which is true. 0 is equal to 0. Actually, there's a third possibility too, and the third possibility is that A is 0 and B is 0 as well. But the point is that, I mean, in that case, it's pretty obvious that obviously if A is 0 and B is 0, then obviously 0 multiplied by 0 is going to be 0, and obviously that is obviously clearly equal to 0. But the point over here is that I don't know, either this thing has to be 0 or this thing has to be 0 so that this equation remains true. Either A needs to be 0. If A is 0 and you multiply with B, then obviously this equation is going to remain true because A is, you're going to have a 0 is equal to 0 situation, which is obviously true. Now B is going to be 0, then that's just going to be A multiplied by 0, and that's just going to be 0 is equal to 0. Now this situation is true as well. Now imagine if A is not 0 and B is not 0, what's going to happen in that case? So A is any other number, let's say A is 1, and then let's say B is any other number, let's say B is 25. So now 1 multiplied by 25, and that's just going to be 25 is equal to 0. This is not true, this is incorrect. 25 is not equal to 0. So, and in fact, either A has to be 0 or B has to be 0 for the equation to be correct, for the equation to not be wrong, for the equation to be mathematically correct. And since I was like, this thing is A and this thing is B, that means that either x minus 4 has to be equal to 0 or x minus 2 has to be equal to 0 so that this entire thing is true. This entire thing remains true. Because if any of these things, let's say if this is not 0 and this is not 0, so this is not 0 and this is not 0, then obviously I'm going to get some other answer. Let's say this entire thing is 1, let's say this entire thing is 2, and then I just multiply 1 multiplied by 2 is equal to 0. I'm going to get my answer. It's 2 equals to 0. This is not going to be correct. This is incorrect. So I hope you understood what I just explained. If you didn't, then when you're at your final step, x minus 4, when you're at this step where you're in your factorized form or where you're in your root form, if you didn't understand any of what I just said, just take x minus 4 equal to 0 and take x minus 2 equal to 0. Just take those two brackets equal to 0. If you did understand, then that's just perfect because this thing has to be equal to 0 and this thing has to be equal to 0. Only then will this equation not be incorrect. I hope you understand that. If you don't, then just take each of the brackets equal to 0 and solve them. So this is going to be x is equal to positive 4 and x is equal to positive 2. These are your two answers, and so you found your roots. You were trying to find your roots, you found your roots. These are your two roots. Now you could have converted this into the completed square form, done it that way, or you could have just used this factorized form, the version I did, and I would actually encourage you guys to go ahead, try the completed square form, do that, and you will actually get these two roots of plus 4 and plus 2. And remember one thing, that in completed square, you're basically going to get this form ax plus b squared plus c, and obviously it's going to be equal to 0. So when you take the c to the other side, it's basically going to be this thing, and when you take the a to the other side, it's basically going to be this thing. And then when you take the square to the other side, it's going to basically be plus and minus square root. Okay, remember that. It's going to be plus and minus square root. Don't forget these pluses and minus signs. So you're going to do it one for plus, and then you're going to do it one for minus, and then it's going to basically leave the two answers. If you just solve it for plus, you're just going to get one root, and you're going to miss the other root that was going to come from this minus sign. And so maybe you're going to find this 4, and maybe you're not going to have that 2. So be careful of that. When you're solving this and you take this 2 right over here to the other side, don't forget that it's going to be plus and minus square root. Don't forget that point.